Okay, there's nothing new in this example, so I suggest that you try this one on your own. Do try to set it out properly, and do come back and watch the video to check your answers, and crucially to set your showing, to check your showing enough working. So for the first one, we've got an n here, we've got a p here. We need the list of outcomes. I'm not going to put them all up to 30. They go from 0 to 30. I'm interested in ones near 16. So we need the diagram, dot, 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 dot. Okay, x being less than or equal to 16 is all of these up to 16. So it's this one here. Okay, so this is the simplest possible case. I just looked this probability up directly on my calculator. That's what I need. And 0.8644. And this is the only case really where the diagram isn't strictly necessary, because this is what your calculator tells you anyway. Similarly, on this one, we've got a new n, a new p. Put them in, and we get that probability. But for every single other example, I will need my inclusion box and my exclusion box. So if you haven't started trying these on your own yet, do that. Make sure you start each one with a diagram. Say for x greater than 4, can't be this, can't be this, can't be 4 because it's strict, can be any of these. Inclusion box, exclusion box. The inclusion box has got everything, so it's 1 minus the probability of x being less than or equal to 4, which is 1 minus, we've got this one already. So the answer is 0.94077. For the next one, do your list of outcomes. My only tick is 4, everything else is a cross. Inclusion box has got to catch the 4. Exclusion box has got to get rid of all of these crosses. So I need to do the probability of x being less than or equal to 4 minus the probability of x being less than or equal to 3. This one I already know, 0.05923. For the second one, repeat the calculation, x is 3. So it's that number there. Do the subtraction, preferably on another calculator. And there's my answer. And here it is. Next one, list of outcomes. Strictly less than 7. So that's all right, but these aren't. Inclusion box. And I notice that I just need one probability. It's the probability of x less than or equal to 6, because there are no crosses in that inclusion box to get rid of. So that's a straight probability, less than or equal to 6. That number there. There we go. Next one. X is greater than or equal to 6, so I can be 6 or anything bigger. This is a tick. But I can't be things less than 6. Inclusion box has to have everything. Exclusion box, get rid of the crosses. So I need to do 1 minus the probability of x being less than or equal to 5. As long as I do this diagram, it's going to be easy. Probability for x less than or equal to 5 is that number. Subtract that from 1 and I'm going to get 0.8491 to 4 significant figures. Last one, diagram of the outcomes. What am I allowed to have? Well, certainly not 0, certainly not 2. I can have 3 because this is a weak inequality. I can have 4. I can have 7 but not 8 because this is a strong inequality. Cross these out. Inclusion box, need to catch that 7. Exclusion box, need to get rid of these horrible manky crosses here. So it's the probability of x being less than or equal to 7 minus the probability of x being less than or equal to 2. This line is always worth writing down. Do them on my calculator. Here's the one for 7. Here's the one for 2. Now, if you don't like your calculator showing you numbers like this, the way to change it is to do Shift, Setup, okay? For number 3, number format. Now, we want the normal one, but we want version 2 of the normal number format. So that is now showing me in a more friendly form what the number is. If you were struck by this one being exactly 0.5, notice that we've got an exactly 0.5 value of p. So when we first put in p, we've got 0.5. Okay, so with 15, there are exactly 16 possible outcomes, because 0 and 15 are both included. Okay, so if I go up to 7, that's the first 8 outcomes, and they'll have exactly the same probabilities in reverse order to the last 8 outcomes, because it will be symmetrical. So that's why 7 is exactly half the cases, it's exactly the bottom half, so the probability is exactly a half. Anyway, you do this subtraction, and you get 0.4963. That's 4 significant figures, that's enough. Okay, so this question took almost no time. So don't skimp on it. Don't miss out the possibilities diagram. Don't miss out on this explanation step. If you put those things in, then you'll very rarely get one wrong.